talking about synchronizing state in the multi-device world. Because we definitely live in a world where like mobile is taking over. Mobile apps kind of are starting to dominate the marketplace, and it poses interesting challenges that we haven't had to deal with in a while. But before I get into that, let me tell you a little bit about myself. I'm Jenny. I'm a developer advocate at a company called Firebase. What that means is that I managed to find a company that would pay me to come and talk at conferences and play around at hackathons and help people like you build really cool stuff. So, yeah. And I have social media links up there if anyone wants to like ping me on social media. I love hearing from you. I love hearing what kind of cool stuff people are up to. So feel free to ping me on Twitter, or I guess Google Plus is up there if you're Google Plus inclined. Let's get into it. So we're going to be talking about synchronizing state in the context of a fictional startup called Trendy Startup. So I'm going to tell you a little bit about Trendy Startup and the kind of challenges that Trendy Startup is facing as it goes to try and raise its first round of money to start a business. Then I'm going to give you Trendy Startup's pitch, which I hope you find enjoyable. And then we'll dig into the code and see how it actually worked. Sound like a plan? Okay. Let's talk about Trendy Startup. So Trendy Startup is a tiny app company. So they're small. I think there's like 3 people there now, let's just say. Why not 3? They're young. And they specialize in solving important, critical problems, but narrow ones, across many different platforms. The kind of case that a lot of startups deal with these days. You pick one thing to kind of knock out of the park, and you try and get to you try and get your solution to as many people as possible. And by many devices, I mean all the things, like, I guess there's Google Glass over there, there's a tablet, a phone, I guess that's a laptop, or maybe it's like a tablet with a speaker bar attached. But yeah, all the devices. We want to target everything out there, everything that someone could pull out of their pocket, almost everything. And this is the kind of case we live in now, where like a user will pick up one tablet, they'll pick up their iPad, and they'll change something in the app, and they expect to see it right away on like their Android Wear Watch or on their web browser. That's what I mean by many devices. And the kind of apps that really kind of strike a chord these days are more than just great software. A big part of it is getting your usability right, getting your software great, high quality, but data is becoming more and more a part of it. And there's all sorts of different kinds of data we got to deal with. Each one has kind of its own dynamic. Like you might have user preferences and settings. That has a very different kind of profile and a way you treat it versus like user-created media, like the photos they might upload or the videos they might record. And then we have more and more stuff that makes use of sensor data, like GPS, location, activity recognition, contextual awareness. And that's another set of data that's also completely different. You have enormous amounts of records of very, very small chunks of data. And then we have another case that's one of the most tricky to deal with, which is real-time state, which is kind of the interaction state. Let me dig into that one a little bit further. What the heck do I mean by real-time state? So here's an example of real-time state. Say I'm making an app that tracks buses. This is actually where buses are in San Francisco, the city I'm from. This is where they are as of about 100 milliseconds ago. And this is an example of like real-time state. So if I'm sitting on a corner and I have my little app out and I want to know when my bus is there because it's supposed to be there, and schedule says it's supposed to be here, why do I see no bus? This is an example of data that needs to be really fresh. It needs to be real time because when that data is 5 minutes old, it's much less useful. Yeah, knowing where the bus is 5 minutes ago or an hour ago, not useful at all. But knowing where it is just this second and knowing that like 2 47s are right next to each other, 3 47s are within 3 blocks, that might be useful. It's like, oh, apparently that bus line's kind of messed up. There's 2 more down there right next to each other. What the heck? Buses. I wonder why so many are stopped. I guess it's like, rush hour is over there. No explanation. That is where they are, though. Another example, collaboration. Think like Google Docs collaboration. And this is an interactive slide. So if you go to tinyurl.com/firedraw, you can draw on this board with me. This is an example of a case where, if I'm doing collaboration, like we're on a call and we are kind of whiteboarding something out together, if it takes long periods of time for the data to go back and forth, the experience is going to be a lot less awesome. See, no one has braved the whiteboard yet. You have to trust me. It does work. It refreshes really fast. I love interactive slides. One more example of real-time state. My favorite one. Games. This is another interactive slide. And this is an example of data that even a few milliseconds hold. Like if we're playing multiplayer asteroids and we're trying to shoot each other out of space, the position of those little projectiles, whatever they happen to be, that's super important. If that's even a few milliseconds old, it suddenly becomes a really clunky game and the data becomes pretty much useless. And like the data that was recorded in this game is completely useless even like minutes later, because you probably don't care what happened in the game last week. No one wants to play asteroids with me. Okay, maybe later. I have to click out of the canvas to advance the slides. Boop. Let's click on the little button. Cool. And so back to Trendy Startup. Trendy Startup really wants to target this real-time case because they're seeing it come up more and more. Everything from social network news feeds to document collaboration like on Google Docs and that kind of stuff. It just seems to be something that's kind of baked into all the really successful apps they're playing with. And talking to their peers who have had recently funded startups and the venture capitalists around them, they know that that's really important. They also want to hit a few different platforms. They want to hit Android, iOS, and web. This is just because these are the devices that the people at the company happen to own. They didn't do research or anything. And there's this Internet of Things bandwagon. Some of their friends who recently had successful startups did this Internet of Things thing. At least they had Kickstarters that made money or something. And they want to get on that bandwagon too. So they want something that'll work with some kind of thing. Okay, sounds interesting. So first thing they did when they kind of started their company and they were hanging out on the weekends in someone's garage is they did kind of a lot of evaluations. They tried a lot of things to build their app and get their pitch going. Because they had a lot of data to kind of move back and forth between all of these devices. They tried building kind of mesh networks, point-to-point stuff. They tried Z-Wave, and they set up Zigbee mesh networks and that kind of stuff. They wrote their own backend. So they've done it a lot. They have experience in web startups. So they got their SQL database, all that kind of stuff. And then they tried another one, which was a cloud backend. A backend is a service. Cloud all the things. And this is kind of what happened. So first they tried the point-to-point thing. They did a little hackathon, you know, they stayed there a weekend or whatever. Set up a Zigbee mesh network probably, because why not? And it was super fast. And it was cool because it worked even where there wasn't an internet connection. But they quickly decided that it was not really going to work that well, because first of all, like, how many of you have a Zigbee mesh network at home already? No one. Usually one person has a smug look on their face and raises their hand. And the support, but really kind of like cross-device support is really what kind of killed this one. So they got a sad face. What I mean by that is they kind of had an n-squared relationship between different devices that they had to verify at some level. Because each one of those devices is a little bit different. It has its own set of quirks. And making sure that like a Galaxy S3 could establish that Bluetooth link with an iPhone 5S. Like they ended up having to do a lot of those combinations to validate that would actually work and guarantee quality for their customers. Because people will try an app kind of once before they kind of get frustrated and move on to the next thing. Just got to work. Too much complexity. So it got punted. They also considered rolling their own backend, which is where a lot of us go because we have experience in it. In fact, the CTO loves writing server code. So he was like, yeah, let's do it. And they knew that whatever they built was going to fit their needs perfectly because they built it themselves. They would have just the right amount of features. They wouldn't have a lot of extra stuff they didn't have to deal with. But even though it's something that's comfortable for us, because we've done it a lot, we know like where to put the SQL server, where to put the memcache, when to start caching this or that. We've gotten a pretty good feel for it by now. It's something we've been doing for years. But you pay a lot of time to do that. You end up writing a lot of code that looks a lot like code you've probably written before. It's usually a sign. They're like, okay, we need to move fast because we know that Fancy Startup is working on the same idea. We need to make sure we beat them to the market, right? Yeah. Sad face. So they decided to try the thing that was a little scary. Backend as a service. They went and they found there's all sorts of backends as a service now. There's all these places where you can, where these services focus on making it so you write as little code as possible and you use as many features that are already built by some cloud provider, whether it be like Amazon, Google, Azure, and a lot of other smaller ones have these great things that can save you tons of time. And it makes it a lot easier to get started because a lot of that stuff's already written. Also, because they end up with a much smaller code base overall, they can pivot faster, which is a really kind of important thing in startups. At least in San Francisco Bay Area startups, they seem to pivot just on a dime randomly. They decide, I'm bored of that, or somebody's beating them to that. Anyway, good ones also scale kind of automatically. So a lot of us have really good experience making scalable systems. We know, at what point in traffic we're going to need the memcache. We know how to read all of our Java dashboards to figure out, when we need to start sharding data and all that stuff. But why do that when someone else can do it for us? Like all these systems are good ones are designed to scale automatically pretty well. So we don't have to do it, which is nice. But there is that risk of lock-in. This is something that always comes up, which is if I use a whole bunch of these proprietary technologies, because most of these platforms as a service are proprietary technologies on top. And then at some point, if I want to leave, it's going to be very costly. So they thought a lot about it, and it's well, we don't have any time now, and we don't have any money, and we're working out of somebody's garage. But if we raise money later, and we need to, we can always use, buy a way out of lock-in then, when we have more resources. Okay, so they got a happy face. Mixed feelings about the lock-in, but let's build some stuff. Let's try evaluating things. So, would you like to see their pitch? The mysterious product I haven't mentioned yet. So, I mentioned this Internet of Things company, and the thing they want to attach to the internet is fruit. They think that fruit has not had enough internet attention lately. So, they are going to build a system to detect fruit. Oh no, I have some cache data there. Let me go give that a... It's getting voltage. Oh no, my demo's sad. But whatever. Roll with it. It should be saying none right now. But they wrote a real-time fruit detector for a whole bunch of different platforms. You got your iOS version. You got your Android version. You got your web version. And the way it works is you take these two awesome probes, you stab them into your fruit of choice. The device itself is wireless, but its interaction with the fruit is not. And let's see, did it actually pick stuff up? Sadly, I think it might have crashed. No! But pretending it worked, let's hack the database. Oh my gosh! Really, really fast, we got updates right away. And if we go, and we stab it into the other fruit, which is of course willing to do it, it's slightly destructive. Boop! But it looks like it crashed. No. But what would happen is that device would then go, change that to Apple, and then everything would change. Okay, demo effect. But let's pretend that worked. And it was awesome. It was awesome. Thank you. Where can I buy one? Where can you buy one? Well, that's exactly what we want to hear from the VCs. So if any of you here are venture capitalists, we'll be talking about what our cash model is soon. Anyway, let's go back to full screen. So there's our silly, silly, silly idea. Much the same as many startups these days. So how did this thing actually work? What was going on here? So it takes advantage of fruit has acid in it. If you stab two different metals into acid, like zinc and copper, like this plug adapter and this zinc screw I found on the floor somewhere, if you stab them into a piece of fruit, you actually get a voltage out, like basically a battery. If anyone's done a potato clock when they were a kid, exact same idea, except as it turns out, navel oranges and Honeycrisp apples produce slightly different voltages because I guess there's something with them that's slightly different. Honeycrisp apples produce more voltage, just in case you ever have to run a clock on fruit. And what it does is we have a little Arduino, a little microcontroller, which are like amazingly fun to play with. And it is reading the voltage from the fruit battery into an analog input, which it then sends over to Raspberry Pi. This combined thing is called a NodeBot. It's using JavaScript. And then what it does, it takes that data and it pushes it off to the cloud. And it doesn't care. At that point, it's done. It just takes those samples, pushes them off to the cloud. And then we have our other clients who are all listening to changes from the cloud, including this slide deck, the reveal.js slide deck platform, very important to support with your startup. And they just react to it independently from there. Let's take a look at the components of the NodeBot, what's in this mysterious cardboard box in a little more detail. We have some electronics. Yay, electronics. Those are just really the copper screw, a pull-down resistor, and the little copper plug goes into the Arduino. Arduino reads those on a little tight C code loop, it's running a protocol called Fermata, which allows it to use serial communication to communicate with a Raspberry Pi. And the reason we have two computers here is that the Arduino is really good at reading those analog voltages, like voltages that are the difference between an Apple and orange battery voltage. But it's not very good at connecting to the internet. The Raspberry Pi, on the other hand, does not have very sophisticated ability to read. It cannot read analog inputs, but it has a really great way to communicate with the internet, especially like if we want to communicate these days, we want to do something secure. So we need at least enough oomph to fire up a secure socket layer TLS connection. And then it sends it off to the cloud. Yay! NodeBot work. And this is the code that's running on it. It's actually super simple. It's using this wonderful library. I love this library to bits. It's called Johnny 5. Actually, named after a character in a movie. And it is a Node.js library for interacting with microcontrollers over the Fermata protocol, which goes over serial. And the cloud database that Trendy Startup happened to use happened to be my employer by pure coincidence. It's called Firebase. It's a great one of many options for cloud, but it works great for this particular real-time data case. So they got a couple things in their Node.js thing. They initialized the board, as you do with Johnny 5. They initialized the connection to Firebase, this wonderful database, which if you go to now is actually publicly writable. So if you want to monkey with the demo, go ahead. Then there is, once the board initialized, once it was able to connect to the Arduino, they started reading, they started pulling that analog pin. And they're pulling about every quarter second, which pulling might not be a good design pattern for web, but it's fine for fruit. It doesn't care. It does not, it can handle any load of pulling that voltage. Once we get the voltage in there, then we do a beautiful if tree thing. Go down, and we get some voltages. As it turns out, if you have less than 20, you probably have no piece of fruit there. There's just a little bit of noise on it. If you get between 20 and 92 off of this, which I guess is like a half a volt, you have an orange. And if you have more, kind of in the 1 volt range, you have an apple. It does that, and then it takes it and just pushes it out to the cloud. And then it's done. It just does that every time the voltage changes. It tells us the fruit type that it figured out, and also puts the voltage that's been converted. And that's it. That's all the stuff that's actually running on the device up here. Client code looks kind of the same because my slide deck is running JavaScript, much like the NodeBot, which is kind of nice because the code looks pretty much the same. I connect to the same database in the cloud, and then I just listen for changes to that value. So I'm listening to the same path, the root/type, which is cool because now that's my point of communication between these two platforms. And then I just take that and I just apply it to the HTML. So I'm just taking that, and then CSS takes care of the rest, which is pretty cool. And iOS, Swift is the new trend right now. So we wrote our iOS app in Swift, and this is pretty much the whole app. So we're doing the same thing. We're connecting to that same database. We are waiting for changes to the value up there, and then we're reading that, and then swapping out an image on our UI. Pretty straightforward. Android code, pretty much the same thing, except more because Android. Android code's a little bit wordy sometimes. But same deal. We're grabbing the image view, we're taking it, we're listening for changes, which is an anonymous class. And then we are on the change, we take that same thing, and then set an image to the right field, the view. So, why is this cool? Well, if you take all the code to do that entire thing, that synchronizes all the stuff across all the platforms and has a terrible but working app on every platform, It's less than 100 lines of code total. So this is the kind of thing you can crank out pretty fast. And we actually, well, it normally works, but it worked. The mobile apps worked. And the code on each platform is idiomatic because we chose a cloud provider that matched the platform. They had good offerings for the platforms we wanted. And each one of those, each cloud provider has, slightly different things they focus on. It just happened that Firebase lined up well with Trendy Startup. And all those clients are independent of each other because there's going to be some features that you want to put on one platform but not the other because they're a better fit. Like, for example, on Android, integrating with Wear over a local connection would make sense. Would not make as much sense on iOS, although Apple Watch is out now, so it would be different. So each client is independent, which is cool. And also, if one breaks, the rest keep working. They just need to know that that data is in that cloud service. Yep. So, wrapping up. These are the things we talked about. Talked a little about Trendy Startup, saw its pitch, and the code that powered it. And what I kind of want you to take away from this is there's a lot of little problems we deal with, like a lot of little things we prototype, like we have hack weeks at work and all that kind of stuff. And projects that have a lot of opportunity to grow. If you find a cloud provider that fits your needs really well and you use it, those projects can grow into real features that you release surprisingly quickly. So it's always worth, especially if you have something you want to make a core feature, finding the right provider and getting it to work on them can be huge, huge value. And it's not as scary, nowhere near as scary as lock-in. And of course, Epilogue. What happened to Trendy Startup? They got funded. Yay! But they failed to solve some of the problems with different kinds of vegetables because apparently they didn't give enough voltage, the pickle matrix, although I guess pickles probably might give a little bit. They were forced to pivot. So now they're the GeoCities of gourmet sandwiches. But they were able to reuse a lot of what they did because they had such a small code size. And that's it. The end. Any questions? Fruits, the world, or anything?
So buses.
Yeah.
That's a real application, and why is that available in Atlanta? The MARTA buses and stuff here.
Oh, the bus slide? Yeah. So that one is the way I built that slide is I have about 30 locales that actually publish that data. So I don't know if MARTA makes it available via an API I could crawl, but I'll check and see if I can add it. That's actually what we have is called an open data set, my company, which is data that we get from public providers that we make available to everyone, kind of like PubSub. So anyone can use that data to write apps. And there actually are a bunch of apps in the App Store, like I think SF Live Bus and some other ones that use some of that data to do bus prediction. We also have currency and earthquakes and parking and stuff like that. They're great for hackathons.
So I saw that there's a callback function that you have written to update.
Config function? Callbacks, yes. Which one?
Can you go back?
Pick your platform. JavaScript, the web client. Yes, callback.
Behind the scenes, so Firebase is actively polling for changes to the.
So that's the thing, using the more abstract of the platform as a service you can get, the less you care about it. So from our API, all you really care about is that if something changes, this gets called, and then the client manages most of that for you.
I got that. I was wondering about behind the scenes.
Behind the scenes. So what's actually happening is, what is happening behind the scenes? There's a client library that has a local cache of data. So it's going to be using local data whenever it can. It has a connection it keeps to the server, which depends on the platform and the network situation and stuff like that. But it's usually going to be a WebSocket if that's available. If it's not, it's going to fall back to a different socket, use long polling, whatever it needs to get that data to transport. And then it's going to use that to synchronize the data. And it's about as fast as a network round trip. So it ends up being 50 to 100 milliseconds.
What is Firebase? Which category does it belong in?
So Firebase is a hierarchical NoSQL database. So you take your data, and if you can represent it as a tree, it's a good fit for it. It's also really focused on rapid development. Yeah, because there's a lot of tree APIs out there. The thing that makes Firebase different is a simple, slim API and lots of support. Any other questions?
Display your last slide.
My last slide with the slides and stuff. The slide about the slides, the meta slide. And the code's up there, and it works, so you can go play Asteroids if you go check out my slide deck, which is a lot of fun. And you can play against everyone else. You got to check out the slide deck, too. Any other questions? I saw one more. Yep. Preferences sync. Yeah, so I mean, like Firebase does stuff in real time, but it doesn't have to be real time. And preferences are a kind of data where you have a pretty small data size, and it's good if it updates quickly across things, especially if you're using something like, you know, if you're using one device as a remote control for another. Those situations is probably going to work really well. So what I'd encourage you to do, and in general, is experiment. Go try it. Give it a spin. See if it works. And if it works, you should probably be able to figure out pretty fast. Like a good platform that you're using, a good cloud platform, you'll know pretty fast if it's going to be a good fit or not. If you're still undecided after a week of hacking, it's not a great sign. Pricing. Okay, I can bring that up. Pricing on Firebase. So it's free to get started. So if you are doing a side project or something, I'll pull that up now. Firebase.com/ oh my gosh, pricing. Once that header loads, site menu. So it's billed by concurrent usage. So up to think about multiplayer games, that would be simultaneous players. So it's simultaneously connected clients up to, so that there's a free plan that gets you up to 50, which is plenty to do hacking and experimenting. And then after that, it's billed by concurrent. And there are self-service plans that go up to like 10,000 concurrents, but you can negotiate. There are negotiated pricing plans that take plenty more if you need 1 million concurrent users. But if you're doing like preferences or something like that, you're probably not going to need very many concurrent seats. Because it'll be like, connect, get data, done. Set, done. Anybody else?
Should I assume there, like code for Arduino, like how it's written?
The code for the Arduino, that was, let me go back to that slide. So the Arduino is, I'm actually not running much code. Hey, it's working again. Oh my gosh. But it guessed wrong. Oh no, this apple is less acidic than the other one. There it goes. Yay, so to everyone who's still here, I will actually demo it. So the code on the Arduino is, Arduino comes with a sketch for Fermata. Yeah. Sorry? Oh, okay, the repository. So all the code on there is, so if I go to code, synchronizing straight, Firebase fruit detector. Did I forget to push? Oh, it's in this device directory. So that's the Node.js code that runs on the Raspberry Pi. The code that runs on the Arduino itself is just the Fermata sample. So I should probably put better instructions here. Do I have it? Oh, here it is. So what you want to do is you want to install what's called standard Fermata onto your Arduino, which I can show you right here. If you bring up your Arduino IDE and go to mysteriously examples, no, I don't want an updated version. Examples, under examples there is a Fermata section, and then there's standard Fermata, which is what you can use to communicate with, like, there's a whole bunch of stuff. Johnny 5 is one library that uses it, but there's a whole bunch of stuff that uses Fermata. And it's weird that it's in examples because it's not actually an example. You're probably not going to want to modify it. You're just going to want to push it to your device. And it's like, it's you know, you can read through it. It's definitely digestible. Like, it's only like 1,000 lines of code or something. And it's pretty straightforward. So if you want to see what it's actually doing, because it's not terribly fast. Like, it runs at like whatever, 115 kilohertz or whatever can get off that serial port. So if you're pulling a sensor at like 6 megahertz, you might want to modify it a little bit to get some compression.
These synchronizations, do you ever get SLAs where people come to Firebase or whatever, and then if you don't make it in this time frame, there's a penalty, or you're not meeting your guarantee?
So is there an SLA on response time for synchronization?
Is there any of those types of issues that you have had to deal with? Or?
So in general, if it is up, it's going to be about as fast as the network round trip, because the time for the server-side stuff, and this is actually pretty common across pretty much all of the cloud providers, you're connecting to a data center somewhere. The time it takes that round trip is usually much faster, or the time it takes you to negotiate a new connection if you're doing like a RESTful system, especially if you're using TLS over RESTful, then you have like 6 round trips then. But that time actually usually significantly outweighs the server-side time, unless you're doing a completely bonkers query. And so in Firebase, we don't make an SLA about that part. We just kind of have an SLA about uptime because networks are unpredictable. But it works pretty well in most places. I mean, it's pretty good at catching up and handling the jitters in the network and handling short duration offline and resyncing. But if you have stuff that's that critical, you're probably going to want to work at a little bit lower level. So you can implement your own quality of service. Because I'm not aware of any cloud providers that are going to be able to, there are some that try and do predictive stuff for latency. I think some of the gaming platforms are the best for that.
So is this mostly like a lossy type of communications, or is there guaranteed?
So the question is, the communications lossy? The communications is not lossy. Well, it depends on the situation. So what it does is it guarantees that it will get the clients up to the current state as fast as you can. So that means if you have one particular field that you're just hammering with changes, like apple, orange, apple, orange, apple, orange, the fact that it went back and forth might get lost because it might skip a bunch of deltas, especially if you go through a tunnel or something. If you wanted all that history, what you do is you just push all of the deltas on with timestamps, then you'd synchronize that whole set of data later. So you can implement it in either way, depending on your application. But if you want the data to be persistent and get all the data everywhere, that definitely works.
No, but lossy is that I mean, you can just set it up that way and configure it that way.
Yeah, if you wanted a lossy implementation, you just modify. You just use a set method instead of like a push method to just assign to a certain spot. So assignment. Hey, any other questions? Cool. I hope you found that enjoyable. Hope that was fun. Thank you, everyone.